Oh, meron siyang Rust translation. It has a Rust translation. Okay. Anyways, and let's detach the chat here. Ayan, para kita ko lahat. Let's see our TikTok kung okay naman siya. Kasi hindi ko magkano to. Ang lakas. Ano lang kaya siguro mga 10 or 11. Grabe naman 12% to, napakalakas. And I think this is okay. Water muna. So now I'm studying a new book, and this is going to be my focus for the entire remaining of the year. And it's more on AI. But I will still going to use Rust as my main language here instead of Python. And it's quite, I'm kind of also excited because I hope I can use the GPU programming knowledge that I learned from the past and be able to use the NVIDIA Oxide. So it just got released. So meaning I won't be able, I don't need anymore the WGSL if I'm just going to target the CUDA kernel. Okay, where are we now? So this one, stage 1. Just going to finish reading the pages here. So up to tokenizing. Yeah. Hey, Matthias. Understanding word embeddings. So deep neural network models, including LLM, cannot process raw text directly since text is categorical. It isn't compatible with mathematical operation used to implement entire neural networks. Therefore, we need a way to represent words. Okay. I think my sound. Why is it is that picking up my Oh, there's no sounds. Oh no. What happened? Ah, it's the OST. Okay, let's see. Ah, this one. Way to repeatedly. Well, this is 1 hour. I'll just go rewind it later. So we need a way to represent words as continuous valued vectors. So most likely, word embedding is like making the words as a vector. So per character, it will, my assumption, it will be converted to numbers or to the ASCII equivalents. It's embedding. The concept of converting data into a vector format is often referred as embeddings using specific neural networks, a neural layer, or another data in neural network model. We can embed different data types, for example, video, audio, and text as illustrated in figure 2.2. However, this is it's important to note that different data formats require distinct embedding models. For example, embedding model designed for text would not be suitable for embedding audio or video data. So this is the embedding. So deep learning models cannot process data formats like video, audio, and text in their raw form. Thus, we use an embedding model to transfer this raw data into a dense vector representation that deep learning architectures can easily understand and process. Specifically, this figure illustrates the process of converting raw data into a three-dimensional numerical vector. Huh. At its core, an embedding is a mapping from discrete objects such as word images. While word embeddings are the most common form. Word embeddings are the most common form of text embedding. There are also embeddings for sentences, paragraphs, or whole documents. I think my understanding is wrong. Sentence or paragraph embeddings are popular choice for retrieval augmented generation, which is RAG. Retrieval augmented generation combines generation like producing text with retrieval like searching an external knowledge base to pull relevant information when generating text with a technique that is beyond scope of this book. Since our goal is to train GPT like LLMs, which learn to generate text one word at a time, we will focus on word embeddings. I think maganda. Resize. Ito na lang siguro instead of text. Oops. And let's go on embedding some, okay na pala to. Several algorithms and primers have been developed to generate word embed. One of the earlier and most popular example is word-to-vec approach. Word-to-vec train neural network architecture to generate word embeddings by predicting the context of a word given the target word or vice versa. The main idea behind word-to-vec is that words that appear in similar contexts tend to have similar meanings. Consequently, when projected in two-dimensional word embeddings for visualization purpose, similar terms are clustered together. Word embeddings can have varying dimensions from 1 to thousands. A higher dimension might capture more nuanced relationship, but at the cost of computational efficiency. While we can pre-train models such as word-to-vec to generate embeddings for machine learning, LLMs commonly produce their own embeddings that are part of the input layer and are updated during training. The advantage of optimizing the embedding as part of the LLM training instead of using word-to-vec is that embeddings are optimized to the specific task and data at hand. We will implement such embedding layers in this chapter. So meron tayo para exercise. Fortunately, high-dimensional embeddings present a challenge for visualization because our sensor perception and common graphical representation are dimensional embeddings into typical scatter plot. Trade-off between performance. So the smallest GPT model okay. So let's go first to what the ChatGPT is going to say about this. Oh shoot. Wait lang guys Mukhang nadali ako sa sa sounds ko. Ano touch mo sa Java is bilingual software? Nag-aaral kasi ako Actually, hindi ko rin alam kasi never ko chinek yung gano'ng spectrum. Pero usually pag bilingual, you have somehow a advantage to to work on the specific country or yung specific what they call this one company. But let's say kung gusto mo mag-work sa isang Japanese company, mas madali ka makakapag-work since you know Nihongo. But in terms of salary, I don't know kung meron siyang siguro may edge din siguro. Baka mas mataas ang bayad. Depende siguro sa needs ng company. Kasi let's say, madalas ko narinig yung mga marunong mag-Mandarin. Pag bilingual kayo and also tapos Mandarin ka, which is one of the, I guess, hardest language to learn. Mas mas mataas yung sahod daw nila. Which is narinig ko lang So, parang chismis lang for me din. Yeah, mukhang maganda naman siya. Ano siya, meron ba Japanese na programming language? I mean, parang mga Japanese characters pa rin ba yung gagamitin mo when you're writing software? Even though kahit na Japanese yung organization mo? I think parang hindi ata. Parang English pa rin ata. English characters pa rin yata yung gagamitin mo. Although you can interact with Japanese developers and Japanese stakeholders pa din naman. Yun yung maganda lang. Yun yung maganda doon. Balak mo ba magtrabaho sa isang Japanese company? Medyo ano yan when it comes to culture, mas workaholic ang mga Japanese versus sa mga Pinoy. Textonization, tokenitis. The key realization is LLM do not understand words, grammar, semantics directly. They only process floating point vectors, matrix multiplication, probability distributions. So this diagram is extremely important architecture. Really, the book hypertext LLM, stage 1, building infrastructure, pre-trained foundation models, fine-tuned for task. Depende siguro pagka pagka nilagay mo siguro yamet doon sa sa code mo, magbe-blurred siya. Green-minded This chapter focuses only on data preparation and solidity within the compiler planet for language before transformers can execute it. Hindi ko alam kung ano yung sasabihin ni ChatGPT dito. System analogy. Think of LLM like a CPU, transformer, processor, embedding tokens, instruction encoding layer, human text. That must become something like this. Before the transformer can compute it, the core problem. Neural networks fundamentally operate on continuous numerical tensors, but language is discrete symbolic data. I cannot directly multiply. That operation is meaningless mathematically. So embedding solved this problem. What is embedding really? So this is the critical sentence. Ay nako. Warning na naman ng TikTok. Mag-relive lang ako. Ay, hindi pala ako pwede mag-relive. Ganun pa din pala. Hayaan mo na siya. Lang ako. Embedding. Paano kaya kinocompute to? Video embeddings, audio embeddings, text embedding is text specific. This universal concept. Any raw data, audio, images, text, video, graphs can be projected vector space. Embedding table, token lookup. Vocabulary size, embedding dimension. Parang machine learning siya, Vocabulary size, embedding dimension, token, and then context. Ano yung C? Okay. V is vocabulary. T sequence length pala siya. Di pala siya token. Sequence length. So tama, token pala siya. After tokenization, fuck this. Ay, naka. Naban na naman ako ng TikTok. Anyways, restream ko na lang ito. Ay, nako. Ay, nako, TikTok. Nakapikon? Sorry. Embedding, one of the deepest and most important concept in modern AI. If you truly understand embedding, transform will become much easier to understand later. So, an embedding is a numerical representation of something, usually words, sentences, images, etc. products, are transformed into vectors. Example, cat might be. The vector itself is called the embedding. The fundamental problem: computers cannot naturally reason out symbols. Neural networks only operate on floating point tensors, so it must transform symbolic data into numerical geometry. Na naman? Di ba meron? What the heck? Either may nagre-report sa akin or lang. Nag-loop yung yung appeal. Nice. Okay na. Siya, parang is it a formula or something like a parang meron siyang database of, let's say, words or ganun. Embedding dimension. Is it possible? Ayun, talaga niya akong paano. Yung ma-appeal ng ano ko. Yung report. Sige lang, report lang. The fuck? Okay, yes, it is actually the perfect test. You do not need a full transformer to understand embeddings. Tiny vocabulary are talking to ID mapping. Okay. Wait lang. Ito kailangan? Natin. Text tokenized input RAS is fast. ito yung ating data shape, embedding, weights, vocabulary size, and embeddings. So lookup offset token ID times embedding dimension. TRA. Months. Tapos burn. Double GPU rin yung gamit. Okay. I see. So parang may ready-made ng vocabulary pala. So try yung vocabulary. Wait, why am I putting it there? Concept, word to integer. So parang mapping siya, no? Token is the sentence. So let's say Ras is fast. Code hint token. That's galing naman. Grabe naman yung ano. Bagay natin yung aking prenom. Team mahirap sa AI. Hindi ka you will not get the same output. So nangyari ito siya. So nagbago na naman yung aking example, yung vocabulary parang vocabulary sets ko. Convert Alex. Okay. So backup. So let's see, ito yung words, no? Tapos let's see, input. And the cats eats fish. It eats fish. Cat eats fish. White space. Tapos sabi niya dito hint token only. So convert text into token IDs. Expected output to 3. Alright, so we need to map this one. Map word, and then if tapos pero what if hindi siya mag-match, no? Dapat pala baguhin ulit natin. Mosaif. I cannot understand. I cannot read properly your name. Sorry. Oh no, we go back again here. Ras is Past. Ito na naman tayo. So we went back to the same sample input earlier. And now, so this is my first input example. But yeah, input token. Let's say blah blah. Let's say blah. So the most important part, token IDs are just raw numbers in the embedding. So later, but what if the word does not exist in the vocab? Problem plays in the scenario. So how early NLP systems handle this out? So meron siyang parang placeholder, no? So now becomes the model loss information example. Hablas and even. Okay. So we have a fallback token. Okay. So let's have this unknown. Then we can now map it. So vocab and either this one find I guess let's make this one a bit different from the example. So let's use this one as 0 1 never mind. Let's predicate natin is, so we have the word, so BW vocabulary word, and then let's match the vocabulary word. Oops, I think we need to do this. Now vocabulary word is equal to the word that we're trying to find. Unwrap or vocab get maybe we should have something like this. So let's have a constant unknown token. Let's have it as 99. 99 is the, and then let's have a use size unknown token. Building large language model from scratch by Sebastian something. You can check it on manning.com. I think I should put the building LLM from scratch. This one. Let's have this cover photo. Save image. Okay. It went bigger. What the heck? This one. So it's the example is kind of outdated because it's still GPT-3, but I think the foundation knowledge is still there. So it's still good. It's still a good book. And it was recommended also by my colleague that is somehow that is one of the one of my colleagues that are actually into AI, doing AI development. So you can buy this one as ebook or physical in manning.com. I think right now it's 23 USD in manning.com. This one. So you can actually find it here. Actually, this one is a good site, manning.com. Because sometimes they are actually giving free ebooks. And I'm not signed in, that's why that's why it's kind of expensive, but if you actually bought it, you will have the discount. And you can actually subscribe if you do subscription here. Let's say $24, then you can have the access on all of the books or some, most of the books here. It just $24 per month. So I add this one. So all access to Manning books. But right now I bought a physical physical book. So I bought it on Amazon actually. Since I will since in Amazon I will have a lot of choices for the location and more choices for the shipping fee. Because if I order directly from Manning, the shipping fee is quite more than the price of the book. So that's why I go to Amazon for the physical book. Since I'm in Philippines, so the shipping fee is quite expensive. But if you're in US, it's going to be much cheaper. Anyways, let's go back here. Here, a node token, and then collect. So in here in the book, actually, this one that I'm doing is not really not yet in the I'm not yet in the exercises. I'm just trying to add more steps from the book, such as, let's say, embeddings. I'm trying to understand it via code before I go to the next topic. Alright, so better use size. Yeah. Now, why is it vocab still? So what's the error here? Expected, found use. Expected? Huh? So I'm trying to map it and then find. Oh, I see. Okay, get it. Huh. Wait, so if I use find. Sure, I know now. What the hell? If this is what I got by studying Go last time earlier. I studied Go and then my muscle memory is kind of messed up, so I'm now struggling in syntax now. VW that. Wait, so VW is I need to. Oh, okay. I see now. I think I know now. This is quite interesting. So I'm going to map each word, but if I don't find it in the vocab, I will use the unknown. I see. Okay. So let's see. VW. Let's use the VW. And now we can just skip this first. Now we have the option. I think I can do the any here. Yeah. And then because this one is a reference, yeah, double reference. Can just do I just need to defer this one so that I can access the internal reference here. So VW. So it means I found the vocal, and let token ID is equals to vocab. Interesting. I think I can do this. Yeah, find find if VW is equals to, so this already vocal, sorry. So this one should be token ID, and then it will return as token ID use size, and then let's make it to owned. And now we will now do an unwrap or unknown token. Then this one should return. No. It's actually not find. Why am I struggling here? Okay, here we're going to map this. Either bring naman natin. Okay, so I'm iterating through each word, and then I use vocab to map to find here. So to find it here, and then if vocab word is equals to the word I'm trying to find, I will return. So I need to and then unwrap or token. I see. Okay, so let's just do this. If let sound token ID and then for this one just need to use this. So here why is it triple? Why is it triple reference? What the heck? Okay, now so I see. So this one is to own. But thank you for the follow, guys. Okay, so I have now the tokens tokenized. So let's try to print it. Here. So expect is 012. I'm a automation software developer or automation engineer and doing some tech lead also. So kind of hybrid. Sometimes developer, sometimes tech lead. So it depends on the structure of the project. Here we go, the compilation of desktop Rust. Yep, I'm doing on this, but this one is more on learning. So I need to learn more about AI and LLMs, but not just really prompting stuff, but more on the low level stuff of it, so that I can build more complex and can understand it much better. Okay, so 012 the expected, no? So let's have it assert vector 012, and then I get words. And actually, I'm just using what do you call this one? NVIDIA broadcast, so that's why it's kind of fixing my voice. I don't know what's up with TikTok. It's keeping I already received four warnings, or what the hell. There you go. So it should be, yeah. So let's try another input here. Last is meh. So let's try this again. Yep, vector embeddings. Pero ano lang to? Parang simple ano lang to. Vector embeddings. So, in-explain lang sa akin ni Rust kung paano nagwo-work siya. So, ginagawa ko kasi per topic. Tinatry ko kung i-check kung pwede siyang i-translate into words, into code. And then, humihingi ako ng I'm trying to get a use case from ChatGPT so that I can, but it's not going to give me the code implementation. It's just going to give me hints and how step by step. Wala pa ako sa RAG. More on understanding pa lang ng embeddings. So, I just started the book. Chapter 2 pa lang ako. So, later on, I will tackle tokenization. This one. So, yung book is, I bought it on Amazon. But you can buy it here in manning.com. You can buy it as ebook or as a or print. Or I think they also have an online plus audio. So, manning.com. Building LLM from scratch. I think it's more of the beginner book when you want to deep dive to LLMs. So, Rasis may. So, most likely this one is not going to match. So, this one should have the 3. Yeah, maganda siyang ano. I cannot still give comment, pero siguro pagka natapos ko siya, doon pala ako makakapagbigay ng comment sa book. So far, okay pa naman siya. 99 palang inassign kong token ID. Probably siguro doon sa book na binili kong isa, doon ako magta-try mag-rag. Dito kasi is more on yung mga kung paano pinaprocess yung mga input. sa LLM. Baka wala ditong rag. Or baka siguro mga later chapters pa sila. I think okay na ako dito. Parang in-skip ko yung ibang. Yeah, I think already have. Okay, may pa pala to. So you already have 0, 1, 2. You are building a matrix, token ID 0, 1, 2, 3. So vector is 0.2, 0.5. So row is token ID, column is embedding dimensions. So yung first important shape is vocabulary size, which is 4. Let's have it vocab size. Vocab, that length. O nga, no, dapat pala kasama to. I think i+1 ko na lang siya. No, hindi pwede. Ay, ang tanong ko dito, yung unknown ba is part of the vocabulary? Yep. Ako yung magko-code. Kasi if ChatGPT going to give me the implementation, parang, sa akin lang to eh. Parang yung thinking ko hindi na challenge. So it's not challenging me to discover or do further research. Kasi parang gagawin mo, itagrab mo lang yung code, tapos babasahin mo yung code, and then what? Yun yung question ko sa akin. So I just grab the code, I understand how the code works, parang ganun. Pero in theory, do I understand it really? So yung concept ng ginagawa ng formula, ganun. Tapos yung step by step niya. So ganyan yung technique ko actually. Still para ma-force din ako mag-research and to ask more. Mapapansin nyo, gumagawa ako ng follow-up questions kay ChatGPT. Because I'm trying to kamote naman si ChatGPT. Nire-receive na naman akong warning. Nagsasalita naman ako, so hindi niya nadidetect na nagsasalita ako. Anyways, okay na. Pag naban. Saan na ba tayo? Because what I did is reserve a token ID but not part of my hash map. I said I reserve a token ID, but it is not part of the hash map. Critical root. Even if it's not stored in otherwise. Sabagay, size na naman siya. Okay. So, gagawin ko pala siyang ganun, no? No, I'm not using Java. Yep, I'm still using Rust. So, but the book is showing Python. So, Python yung ginamit niya dito. But for the challenge, I will use Rust here. Kasi since yung experiment ko na coding assistant na development is in Rust, might as well as use Rust na rin dito para hindi ko kailangan i-translate later on yung mga matututunan ko from Python to Rust. Tsaka din, gusto ko rin mag-manual code muna sa Rust ngayon kasi sa work medyo nagba-vibe code ako. So para hindi mag-deteriorate yung Rust knowledge ko. Dito makita nyo, hindi ako masyadong nagbabibe code. Or hindi ako masyadong humihingi na AI coding assistant. Okay, so may mali ako dito. I think gagawin ko pala dito is let's turn this one into a function. Since mukhang gagawin ko siya, i-reuse ko ng i-reuse. Map to words to token ID. Ano kasi, madami kasing, mas madali kasing, what do you call this one? Mas madali kasing ituro pag Python siya. And also, yung mga researchers are also using Python. Tapos yung vocab natin dito is gawin natin constant na hash map siya. Can hash map be a constant? Bakit siya naka-warning? Oo, kailangan nakagana siya. Vocab. Tapos, ano problem? Cannot call non-constant associate function. Hindi siya pwede dito. Alright. So, gawa na lang ako ng function. Sige, ito na lang siya. Tapos, vocab na lang natin is hash map of string. I think alam ko na. Gamit na gamit Python specially for Yep, kasi rich on machine learning libraries kasi ang Python, and lagi siya yung ginagamit for data science. So that's why mas practical gumamit talaga ng Python sa mga examples for the book. Ginagalaw ko yung pages kasi baka ma-detect ako ni ChatGPT na na bot. Naka-4 na warning na ako. Baka later on biglang ma-end na yung stream ko. Unknown token ID index na lang siguro. Unknown token index para madaling hanapin. So, dito tayo sa 0, 1, 2, 3. Kaya lang gagawin ko. Tapos, I think need ko define pala yung type dito. And then, this one is static. Oops, tama. Hindi talaga pwedeng gawing constant yung hash map. And declare as constant primary. So, kailangan ko siya ilagay sa box most likely. So, lazy lock. Medyo siya, matrabaho. Dito na lang. Gawin ko lang siyang function. Yep, I'm using Z editor. Vocabulary. I'm just going to return this. Then, let's have this here. Let's just return this. So that I just call this always. Right, and then let's have it here. Let vocabulary. Vocab, yes. Although it's kind of expensive to call this over and over, but it's okay. else here, I think it needs to panic, no, pag hindi na niya makita yung token ID. Alright, so here, vocab, find, and then so if let's sum here, tapos actually I can just do this. Ano to? I'm trying to study a book. So ito siya, yung nandito sa book. Ano ba to? Yan, ayan. Yung nasa gilid. Yan, yun yung book. Since it's option, hindi ka pala ma-access yung and then here, vocab. Vocab that get. Anong danger nun pagka +1 lang yung sinabi ko dito? I'm to think if I'm going to make this one outside the hash map, but if I'm going to get the vocabulary size, I'm just going to do +1. I wonder what's the impact of that. I think there's none, right? I think there's none. Never mind. Yep, Rust. I'm using Rust. Unknown token ID. Alright, so let's go back. Okay, so and then I'll just put it +1 here. No, it's right. It's still physically in the hash map pala. Let's go back. Saan na ba yun? Saan na? So now this is the vector 0, 1, 2. So row is token ID. So 0, 1, 2, 3, these are the rows. And then columns are embedding dimensions. So how do I get these values in the vector? First, important shape contract. Vocabulary size, which I already have, which is the length. Embedding dimension. Embedding dimension. Where did this came from? Columns, embedding dimension. Wait, how did the embedding dimension? Paano siya kinuha? Or paano siya na-determine? How did you determine? Because I get the other one, this one, the vocabulary size, which is the length of my vocabulary hash map, but the embedding dimension is not. It's one of the most important architecture questions in LLM design. The short answer: embedding dimension is the design choice. It's a hyperparameter, not something automatically discovered usually. What embedding dimension means: embedding dimension 4, then every token becomes 4 floating numbers. In example,
Okay. If dimension becomes 768, then rust becomes 700 floating point values. Okay. 768. Para saan yung LLM? Yung ginagamit nating ChatGPT, Gemini. Yan, LLM, Large Language Model. Yan, mga LLM yan. And just studying how it works behind the scene, under the hood. Okay, so here, tiny models, maliliit nga lang siya talaga. So what larger model means, bigger embedding dimension means vector can encode more relationships, more semantic nuance. But there's a trade-off. Memory, more flows, VRAM, larger tensors. Hidden architecture constraint. Modern transformer usually maintains embedding dim or hidden dim. Okay, medyo nag-ano na siya. Important mental model. The width of my model's internal thought space. You only need 4 because, or 8 because your goal is understanding. 8 lang. Ano yung purpose nung parang okay, so parang mapping ba siya ng coordinates in a grid? Hyperparameter. Yep, you're right. This is actually the purpose of embeddings. So part of the LLM is embeddings. I need to turn the move the pages, or else I get warning again. Someone support and embedding hyperparameter or something. I think I need to have another. I need to settle the definition of terms. You set manually parameters. Okay, yung pala tawag. That's the definition. So embedding that, then every token becomes 4 floating numbers. So just converting it to floating numbers. Why must dimension match? So every register must have the same width. So I guess this is for matching. Why do we for a reason, a single number cannot encode enough information about a token. So cat, dog, 1, 2, 3. These numbers contain almost no relational structure. The model cannot meaningfully learn similarity, context, semantics, relationships from scalar ID alone. Token ID are just merely database primary keys. Okay. The numbers 0, 1, 2 have no semantic meaning. The model must transform them into something richer. Embedding dimension create future space. One number we use many numbers. Each dimensions allow the model to encode relationships, patterns, contextual signals, token IDs, memory addresses, while embeddings are the actual data loaded from memory. Suppose you only have 1D space like cat, dog, airplane, very limited. Now imagine 2D space. Cluster distance relationship now scaled to the model gives enormous representational flexibility. Dimensions are not manually assigned. The model learns them during training. That dog will have similar vectors, attention, similarity search, connects by geometric proximity. Without dimensions, there's no geometry. Embedding dimensions created. So parang just it gives more attributes. Embedding dimensions are not extra storage, they are degrees of representation data. So it's like more attributes. Learns the attributes automatically. You must not define them. Okay, suppose we describe animals manually. Animal, cat, eagle. Can fly, dangerous. The columns are attribute features. Embeddings are conceptually similar. Each dimension behaves something like learn attribute, but the real embeddings are different. Real embeddings are not clean human readable attributes. Might weekly encode programming syntax. Ang complex. Inipol spread across. So instead of hundreds of thousands of dimensions, contribute partially to meaning. Okay, I think I will learn this one along the way. Medyo ano siya, it's kinda not easy to understand if I go deep in the embedding part and embedding topic. But yeah, I understand the main goal. It's like more on adding more concept or adding more attributes to the token. So embedding dimension is just manual. Okay, so let's have embedding is for vocal size embedding. Then your embedding matrix is for the meaning for tokens times for floating. The radical mental model. The token ID is not embedding. Means read row 2 from embedding matrix. Wait, how do I compute this? Huh. How do I achieve this one? Embedding matrix. Yung calculation ito. 4 tokens. So I will need to divide it. Input output. Shape becomes 3. Yun naman ako sa matagalang topics. Because we're still learning about in real human that user design. Completely random, then training gradual adjust them. Okay, so random. You're asking, now I understand your question precise. You're asking how were those embeddings numbers created? The answer is for the tutor I embedded them manually because we are still learning the mechanics. But, huh? Ano siya manual? So nagra-random lang siya. Do they need to be unique for each row? Parang coordinates lang siya, no? Okay, so ano bang tawag dito? Embedding numbers tawag. So the embedding numbers need to be unique. Token ID. And it is upcoming pursuit, just study hard, study well. Okay, so we just need to do some random things. Okay, let's see. Embeddings. Embedding. What should I call it? Embedding matrix, I guess. Alright, so we have this. I think this one should be tokens. Now, for each tokens, I need to iterate. And then, since I chose embedding, my embedding dimension is 4. I just need to have a map. And then, range from embedding dimension that map. F32 that I think there's no randoms. Yeah, there's no random nga pala sa standard library. No, this is Rust. Yeah, there's no random random function nga pala. I need to use this. Yeah, this is the valid grade. This is something that I don't know why the Rust thing is not adding the random grade. Alright, so we just need to use rand preload. So let's load everything. And then run generate random F32. Let's call this one let mute rng rand rng and then rng.random. Oh, there's something like this random range, so I can do this. Length kano ba 2.5k ata o 3k? Medyo mahal yung shipping fee ko. Pero I think nasa 1.6k lang siguro yung physical book. Pero shipping fee kasi yung nagpa-mahal. Gusto ko talaga ng physical book instead of ebooks. May ebook naman to. Gusto ko lang talaga ng wait, ba't ganun? Expected F32 found I32. Oh, okay. So do I need to typecast this? I mean type annotate here. Yeah, that's added. So this range, what does this one return? It returns a type of T. Exclusive range. Interesting. What the hell? Anyway, let's see other properties. Anyways, I'll just take this. And then probably general random F32s. Yeah. Generate random F32 and then let's collect it. And then vector of F32. Then we don't need the length. Thank you for the follow. So assign words. This one should be tokens. Oh wait. Embedding matrix. Okay, ayaw niya dito. The method called chaining have not ano daw? The method called chaining might not have bad associated types. So okay, so it seems that I need to put it here. I don't get it. Shit. Alam ko na. It's a vector of vector. Tama ba? And then the vector. There you go. Okay, so let's see what we will have here. Print F of that embedding matrix ko. Bakit isa lang? Interesting to. Pero tama siya, it should be 3. Pero why is it compressed in 1? Why is it the token here is so 1? It's a vector. Thank you for the rose. Hindi ko na-disable yung gift. But still, thank you for the gift. This is so weird. I should have at least 4 sets of this. Which is yeah. That's my expectation. Kung kaya mo mag-aral ng 8 hours per day. The longer you practice, the more you get better. Pero syempre, dapat nag-explore ka ng mga different kinds of techniques and also check mo rin yung code ng ibang tao. And magbasa ka rin ng mga books or theories or articles so that makita mo rin yung mga techniques ng mga experienced developers. Pero usually pag bago ka, mas maganda kung mas madami kang oras na i-allot or ibibigay dun sa gusto mong matutunan. Gradually naman magdi-decrease yan. From 8 hours, let's say, magiging 5 hours na lang yan per day, 4 hours, 3 hours. Kasi you will have the measurement. You will be able to measure naman how long you will study certain topics. So most of the time, pagka unknown pa sa'yo, you need to put more effort or time. Ang weird nitong part na to. the per token, I need to generate. So let's see. If I do this as 4, I'm only generating 1. Yeah, I'm only generating 1. So it means that my tokens has a problem. Yung mga token ID ko. Oh, ano naman ako 0, 1, 2. And then this one, I'm trying to map. I iterate here. So, dapat ganito siya eh. Medyo weird lang. Bakit isang iteration lang yung ginagawa niya? Tingnan natin dito. Tapos, let's do the index. Token ID. Tama pala. Embedding mouse. Tapos, tama. F32 vector. Tapos, nag-iterate ako sa range of 0 to 4. It's either this one is just returning 1. Oh, I think alam ko na. Kailangan pala naka-iterate to. Okay, so I think this one should be collect. I think okay na to. And then di pa rin. Tama, embedding number. Oh, bakit isa lang yung nakuha ko, ano? Or kulang ba ako na... Tama, range naman to. Bakit 1 lang siya? Bakit isa lang nakukuha ko? Ang weird nito. Because pagka ginawa ko to, I will get 0 to 4. Oh, I see. If I do to vector, either gawin ko, alam ko na gagawin ko. Kala ko ganun, automatic siya. So, meaning pala, dapat ganito gagawin ko. Embedding dimension. Hindi pala pwede to. Let's see, 4 muna. Lala naman ang ginawa ko. I will get 4 na dito. Ganun pala yung behavior ng range na yun, no? Ayun kaya lang dito. Generate random F32. Tapos bakit umalik siya sa ganito? Wait lang. Okay, gets ko na. This one should be okay. Tanggalin pa natin yung okay, that's our now row selectors. Sequence lang siya. Wait, why is the vocab size is 3? Okay. So it's not depending on the tokens. So still the vocab size. I see. So I still need to have an embedding here. So ito pala, ito so sequence lang ko. Okay. Okay. I-override na lang natin yung kanina. Input tokens 0, 1, 2, 3. Okay, input tokens 0, 1, 2. Embedding matrix 4 by 4. What exact tensor should the embed look return? So row selected. Resulting shape is I'm not sure what he means by I don't know what's the number 3. Not yet. I'm still on the embeddings. I'm not sure how many steps do I need to do. Oh wait, where's my answer then? Still processing. Oh no, a GPT ate my answer. Oh no, cancel. Shoot, I need to do the answer again. Something's wrong with ChatGPT. I don't know what's the question for number 3. Okay, so selected rows. Okay. Correct. Your output is token count. Embedding dimension is C. Oh, that's what he meant to number 2. The resulting shape is 3 by 4. How does the model know token order? Wait, what does it mean? Next comes a very important question. How does the model know token order? Because currently 0, 1, 2, 3 and 2 would just be different row selections, but embeddings themselves contain no position information. This leads to positional embeddings, which are critical in transformer. Before we proceed, I want you to think about the question: dog bites man versus man bites dog. Why would embeddings alone be insufficient to fully represent sentence meaning? Actually, I don't know. I don't know. Well, let's see. It doesn't hold any positions, right? Yeah. The order of the sequence. they are just indexes, which are unordered. Because bytes can be in index 0, dogs can be indexed somewhere else. But when you construct a sentence, their sequence is not, they can be in different sequences. You just identified one of the biggest. The core problem, embedding encode token identity semantic representation, but they do not inherently encode position, order, or sequence structure. Correct, this is what I meant. Ano specs ng device mo? Actually, naka-PC ako. So, it depends on what I'm doing. So, if I'm doing development that I need an inferencing application, I usually do my coding in my Mac Mini, and then I use my gaming PC as my LLM to host the LLM inferencing application. Let's say the Llama or BLLM or LM Studio or Llama CPP. So I use my main PC since it's the one that has the NVIDIA graphics card. But if only this kind of coding, I use my gaming PC, which is I guess 128 MB RAM, MB RAM, gigabyte RAM, and then 12 BRAM GPU, 4070 RTX, and then 1.5 tera storage, and Ryzen 9 processor. Important, you said they are just indexes which are not almost correct, but that's not right. The embeddings themselves are order agnostic representation, meaning each token embedded has no awareness of previous token, next token, and tama. Then dog bites man becomes, while man bites dog becomes same vector, different ordering. The hidden transform challenge. Transformer fundamentally process tensors, TC, token IDs, and embeddings. Tama ba? I need to be familiar with this variables. Embedding dimension. Okay, C is embedding dimension. But matrix operations does not alone do not inherently understand chronology, sequence direction, grammar ordering. This is why position encoding was invented. Okay. Embedding are actors. Position embeddings are stage positions. The model knows who exists, but not where they are. So a bag of features, not a timeline. So transformer needs both content and position. Medyo ang lalim ng embeddings parang it's somehow I go out of but the offers is actually quite high level. So for now high level pa lang siya, pero mukhang nagdig deeper ako. No, I'm not Braille. Masyadong mataas yung level nila compare sa akin. Ay lang ako, average lang ako. Drama yan, no? Anyways, yan, hindi ako si Braille patawagin nyo akong Braille. This is historically important, and the area NLP system struggles heavily with sequence understanding. Transformers solve this by injecting explicit positional information into embeddings. This is one of the key breakthroughs of the regional transformation page. Lalim na? Okay. Mga mamaya, hindi lang LLM matutunan ko dito, baka machine learning na rin So currently your tensor is TC example. So ito yung embedded matrix dimension ko. have no inherent meaning mathematically. They are merely tensor rows positions. The model must be taught what those positions represents. Hardware perspective. Transformers are massively parallel. Unlike RNNs, they process all tokens simultaneously. This means that sequence order is not naturally preserved by execution order. Chapter 2 pa lang to, kamote. Dumudugo na utak ko. You now understand why it requires both token embeddings. What is token is? Position embeddings where the token is. The combination creates order semantics representation. Manually adding position. Oh, okay. So pala yan. So, okay. Let's go. Let's proceed to step 4. I'm only on step 4. What am I doing? I'm studying LLM, large language model. Now we solve the problem you correctly identify. Embeddings alone do not encode order. So we now introduce positional embeddings. You can't have token embeddings TC. So yep, I already finished the software architecting. So this is a new book. So this one. I think laki ako na lang since di rin naman mababasa yung libro. Ano lang, for requirements lang ni TikTok kasi na may webcam. I don't know why TikTok requires a webcam for learning category. Medyo siguro yung AI ni TikTok may problem pagka walang webcam. Akala siguro niya bot. Transformation does not know which token come per second. Transformation solution. The original transformer paper introduced positional encoding conceptually. Medyo hindi na ako masyadong pupunta sa book kasi pinalalim ni ChatGPT, hindi ko kasalanan to. Siya yung kusa pinalalim niya. I think may part pala akong at may fault din pala yung kung bakit siya pinalalim kasi yung types of question ko pala. Ako pala may kasalanan. Positional encoding. Final input, token embedding plus positional embedding. This is extremely important. Why? Addition. Excellent to think up. Concatenating nesting metadata objects. Transformation is simply X is equal to E plus P. Token embeddings, positional embeddings. Okay. How does this work? Positional embeddings. Why this work? Token embeddings encodes what token is. Positional embeddings, where the token is. Adding them views identity plus order into one vector. Okay, ito may example. Yeah, ito yung token ko. Now create positional embeddings. So I will use the index. You need one positional vector per position. Positional embeddings dimension must match token embedding dimension. But how do you generate this? Must match token embedding dimension. Why? Because vector addition requires equal dimension. Wait, how do they create a position embedding vectors? Same embedding dimension, manually add them to token embeddings. But how does this being generated? Ay, okay lang. Okay lang. Okay din si O'Reilly. Sa work ko, O'Reilly din yung provide niya. So, meron akong full access sa O'Reilly books sa pagka work account gagamitin ko. Magaganda yun, books sa O'Reilly, and updated sila. There are two major approaches. Learn positional embedding. This is the simplest to understand, exactly like token embedding, which also have vectors. These are trainable parameters, just like token embedding. Important. Model learns what first token means, what second token means through gradient descent. You basically have another embedding table token, vocab size, embedding team. Example, table, max sequence select, embedding. So, position 0. Wait, paano yung value nun? Yung embedding numbers nun. Pero kasi to is outside work kasi to, kaya ako yung shoulder. Pagka medyo low, yung budget nyo, hindi kayo, medyo wala kayong budget, medyo gusto nyo lang maghanap ng free PDF sa Google, lang kayo, be cautious lang kayo kasi gusto na ngayon yung nag-embed ng malware sa mga PDF. So, ingat lang kayo pagka sa mga free PDF ebooks. Lalo na't mga nadadownload sa GitHub. Minsan yung mga nadadownload sa GitHub may kasamang malware yan ng mga PDF. I think hindi siya madidetect ng Dependabot ng GitHub kasi parang part nung binary yung mismong malware. Row 0 position. Pero how does it so token ID is position 0, 1, 2. Huh? Instead of learning positions genetic mathematically, sine waves, cosine. Why use math instead of learning? Because mathematical coding generally has two longer sequence. So different dimensions oscillate at different frequencies. PE pos 2i is equals to sine, where pos token position I embedding dimension index embedding dimension. Shit, what the hell is this? Do not memorize the formula yet or na understand the intuition. Yeah, actually, medyo nag-gets ko naman yung way pa, yung sorry, just sinusoidal, learned, rope, open rotary. Your current mental models. Pero paano ka siya i-degenerate? Kasi without using formula, how on earth I will be able to use? Okay, plus dimension. Okay, so I will use sine. So dimension 1 sine. Pero what if I have four columns? Ano yun? Sine, cosine, sine, cosine? Kasi parang x1 and y1, x2, y2. Okay, try nga natin i-check kay ChatGPT. Hello, Plok. Good evening. Parang weird. Yung part na yan. Kasi, wait. Soro, zero. This is interesting. Position. This one is pertaining to position. And I don't know. Pwede mong aralin siya parehas, JavaScript and TypeScript. Pwede masabay yan. Kasi may mga part nung sa TypeScript minsan mag-JavaScript ka. Mas maganda kung aralin mo siya both. Ano gusto niyo pagawa sa Okay, the confusion is normal because position encoding is one of the first place where transformer becomes abstract. You're mixing position embedding dimension. Okay, so pause position token in sequence. Means for dimensions. So original, even dimension use out. Okay. So pagka odd position is I'm using cosine. Position 0. So parang weird, no? So ganun din yung produce ko for position 1, same pattern. That's why real formula includes dumudugo na utak ko dito Okay. Lumalim Pero mukhang okay naman to. Interesting din ako to. Medyo interesting actually itong embedding. It's just that the math behind it is quite complex. So in order for me to generate this one, so still the same still the same for embedding, token embedding matrix, position matrix, I guess. I'm using Rust. Okay, gawa tayo ng generate position value. what do you call this one? Sign. How do I do sign in? Plus, wala siyang ganun. F32 sign. Tama ba? F32 that sign. Oh, okay. Position that. Okay. So I need to convert position mate number. Depende siya sa paano pala, sa position number niya. So kailangan ko palang convert to float. Okay, so gawa na tayo ng position matrix. Okay, so I guess meron akong mali dito. Actually, it's not about the position to eh. Yeah, alam ko na. Still vec F32 pala to. Tapos yung length niya for I in length. Gamitin ko pala to. Tapos values, let push. Position 1. Tama ba? Yeah, position 1 to. Wait na. Parang may mali ako dito. Tama naman sinabi ko. O, tama. Galing siya sa ano ko. Yung sa... Okay. So, token pala gaga dito. Yeah, hindi pala dapat. Ha? Nga na, bakit ako dito naglalagay? Oh, okay. Either enumerate pala to. This one. Because tokens actually holds position siya ng token ID. I mean index ng token ID. Tama ba ako? Medyo nakakalito na ta. Yeah, it's getting confusing. Nakayang sequence length 3x4 shape. Okay. So I think dapat pala tawagin ko itong token embeddings. Position embeddings. Getting harder. Dapat align sila. Okay, so I got this. Pero, and then vocabulary siya. Based on vocabulary size. Position arguments. Oh, okay. So, position. Pero sabi niya kanina based on token and embeddings. Ang gulo-gulo mo. What the punch? Medyo nalito ako dito. Okay, ras is fast. Nakita ng diagram dito. Okay, so okay ng embedding table. Okay. Why? Because okay, token embedding table. Your input sequence. I think may mali ako dito. Nandito ako dito. Embedding table ko is 4x4. Tama. And then, so dapat ito. Yep, I'm using plus. TET, token embedding table. Now, So my token embeddings will be like tayo nito nagets ko na siya. Token embedding lookup. Kasi itong token ko, ito yung mga token IDs ko from the lookup. Okay, so here, ang mangyayari dito is token IDs lookup ko. Ito siya. Malito ako. Parang bumalik ako sa square one. An ID of us 3. Select rows matching token IDs. I think my question is here is, since it's a hash map, so because tokens IDs are in direct indices in the embeddings example, then your embedding table must support 99, meaning must ship at least 100. Huh. And lookup means select row 99 from embedding table. Hindi niya ako naintindihan. Is that the rule of it? Okay, so it needs to be sequential yung mga values. And identify memory layer constant. Okay. So it's a hard rule. Hirap nito ah. Pero I'm kinda enjoying this. It's just that it's so there's a lot of question popping in my mind. Okay, going back here. Ano nga bang question ko ulit? So I have a token embedding table. So I have a token embedding table which is contains now in my position embeddings. Kailangan ko ng diagram. Kung ako ng diagram, excalibur tayo. Draw na tayo na lang. Table. Table. With this one, word. Ayan, pwede na to. Title, ras, is, fast, unknown. Ito yung vocabulary. I think save nga natin to ano. Oras 0, 1. So let's say andito yung fast. Tapos andito yung unknown. Ito siya. Now, gagawa ko ng token lookup. So now, let's say hash map to. Tapos ito index. Vector to. Index 0, 1, 2, 3. Okay, gawa tayo dito. I think tanggalin pala natin to. Ano ba tanggalin to? Ako delete a row here. So here, class is fast. Wait lang. Saan na ba yan? Yeah, I think dapat pala custom to. So 1, 2, 3. Title, word, index, and then yung token ID. Parang ganito ata yung gusto I think this is what ChatGPT wants me to understand. Diagram na natin. Mas maintindihan ko. Now, okay, so here, I will generate my token embeddings. So 1, 4. So this is my token embeddings, meaning vector siya, no? So it's into one dimension. Ano, 2-dimension array. So okay, 1, 3, 4, 5 for the column name. Kulang ako dito. Tama ba? So, per index pa din siya. Let's say, ito siya. Bago ako pumunta sa So, ito yung token IDs ko. Now, token embeddings lookup. Hindi na ako nagutom So, dapat ba ang nangyari dito is So 012 siya dito. Medyo ano siya, nakakalito siya. So mean sa token lookup IDs, ang nakuha ko ito parang ito yung nag-hold na saan. So si token IDs, ang nangyari parang ang lookup nito is minatch na tong input ko. So 0123 which is the index automatically generated, pero ang equivalent, ang mapping niya is 013 based dito sa vocabulary natin. Now for the embeddings, tapos dito sa token embeddings table, ito pa rin, based pa rin siya sa vocabulary hash map, and then ang index niya is based on the vocabulary hash map din. So RAS is 1, 2, 3. So ito yung embeddings, let's say yung mga floating numbers. Now ito yung embedding table for the token embeddings based sa token embeddings lookup pala to. Now this one, ito naka-base naman siya sa indexing ni token IDs. Then yung embedding number niya, naka-base naman siya dito. Pero 1, 3 index niya. Pero parang okay. So parang ganito siya, no? I embed token ID. Parang may something na nalito ako dito. Okay, here, ito yung vocabulary. Then, I'd look up, then create a vector, which has it has an index of 0, 1, 2, 3, and then values niya per index is the token ID. Ang na-map ko dito is 0, 1, 3. Now, I also generated an embedding table, token embeddings table that is based on vocabulary table. And then, it's a vector of 0, 1, 2, 3. And then, based on sa index din niya sa vocabulary table. And then, randomly generated an embedding number. Now, the token embedding lookups is based on the token ID for the index, for the number, for the sequence length niya, which is 0, 1, 3. And then to get the embedding number value based on token ID, so I think in this part ako nagkakaroon ng disconnect. Kasi embedding number, parang may token. So, kukuha ako dito. Tingnan natin siyang ano. Okay, here in the image that I'm going to send, so I have vocabulary table that contains the words and then the token IDs. Now, I have an input of Ras is fast, and then I will create a token IDs lookup, which is a vector, and then the index is based on the sequence of the input. So Ras is fast, so Ras 0 index is 1, fast is 2, and then their value will be the token IDs. Now I will create a token embeddings table, which is based on the vocabulary table, and their indexes is based on their sequence in the hash map. So 0 Ras 1 is unknown is 2, fast is 3, and then I will generate embedding numbers. Now let's go to the token embedding lookup. So this one is based on the sequence token lookups ID, which is 3. Now the index is 0, 1, 2, 0, 1, 2, and then the embedding number is based on token ID, so that I will map to the embedding token embeddings table. So 0 to index 0, and then token ID goes to index 3. Token ID 1 goes to index 1 on token embeddings table. Am I correct? And yet already ba yan? Anyways, wait. Shit. Okay, your diagram is mostly correct. The key correction is token embeddings lookup index 0, 1, 2, 3. Okay, here 0, 1, 3. Ras is fast. Tapos your runtime token IDs is 0, 1, 3. Then you select token embeddings are, yep, tama, 0, 1, 3. So I think the vocabulary should be still a vector, no? So your diagram is right. Index means the position inside the current sentence, while token ID means the row to fetch from the embedding table. For the position embedding, later use the sequence. Yeah, the answer is both are usually needed, but they serve different purpose. Vocabulary lookup structure, you need something that answers for this hash map is ideal because lookup. Nga pala, no? I see. I think I missed that part. Kaya nga pala dito pala pwede nga pala yon. I get it na. So dito pala, I think I made a mistake here. So vocab that get that word lang. So I will get now the token ID here. Yeah, for faster lookup siya. Tama siya dito. Okay, so for faster lookup. Shit. Ito sinave ko. Ganun kasi controls nito, mga kaasar. Sa embedding table, 0, 1, 2, tapos token embedding natin is based on sa table. So, gagamitin ko tong token ID. Get. So, token embedding table ko. Hindi na siya generate. So, parang i-get ko na lang siya. So, token embedding table that get. Token embedding table that. Tapos, token ID. Medyo weird lang tong part na to. I think naglalaro-laro na yung utak ko dito. Kasi let's say Porsche. Sige, for the sake of me, moving on. Token embedding, stable lookup. Now, i-get ko siya by token ID, which is yung indexing niya. So, dapat sequential ako dito. 0, 1, 2, 3. Okay, so token ID. So, TID na lang. Tapos unwrap na lang natin siya. Oops. Ano ba, bakit walang IntelliSense? Kasi ito nag-expect to ng ganito. Well, actually, this one will return the type vector cannot be indexed. Token ID lookups. Okay. Medyo nalilito ako dito. Kasi table ID lookups is a vector of usize. So if tama, usize siya. Now, tapos table vector embeddings, tama naman siya, vector of U32. Now, I will need token embedding table that get and then TID. Tanong, bakit ganun? Wala ako. Option siya eh. So, unwrap ko lang dapat siya eh. Natanggalin ko nga muna to. I think ito yung papaloko ng RAS analyzer ko. Hindi ko kasi makita. Itong TID. Vector of vector. Tama naman. Holy shit. Print LN tayo. TID. Wala yung TID. So this is my tokens and then TET ko, token embedding table. Tapos yung lookups ko, I did an iterator. I mapped it. But why is that it's not TID ko 012 and then kuha ko sa token embeddings table get and then TID. Now my problem is why is that ganun yung kailangan ba iSize to? I think iSize ata dapat hindi tama, usize and sign in dapat to. Oh shit, yun lang pala. So unwrap lang natin para magpanic na lang siya. Pero ang alam ko is reference to eh. Sira kasi para sa analyzer to, naglolo ko. Akala ko ang ito is nga no, hindi pala siya reference, type of I lang siya. Oh, that's why. My bad. Ito yung table embeddings table lookup ko. Ito yung TETL ko. So, hindi dapat kasama yung okay. So, sa position embeddings ko, I will be basing it also sa sequence ko, which is yung token lookup IDs ko. Okay, so here, so pag i-incorporate ko ng token lookup IDs ko, same lang din sila nito. Tapos mag-generate lang ako ng sarili ko. So, ito yung position embeddings table ko. Now, for position embeddings table, Huh. Interesting. Why is it? Sa position embeddings ko, kailangan ko lang gamitin ko itong table lookup na to. Mag-enumerate ako dito. Para makuha ko lang yung index. Actually, mas maganda pala sa table embeddings na lang pala. Token embeddings, table lookup. Okay, so ang mangyayari dito is I have the embedding, token embeddings. So vector pa rin sila. Okay, so token embedding, so meaning for I and embeddings dimension. So let value vec f. Let position embeddings table that get, I think enumerate nga ito. E-value pala, e-value at EET. Then token embeddings that get that. Token embeddings. Wala akong parang wala akong, hirap naman ito. Token position embeddings that get I. So values that push is TE value plus PE value. So what's the problem with oops. Ito yung position embeddings. position embeddings. So, ito yung hindi maganda sa vocabulary. Ay, sa hash map. Ito siya. So, mangyayari dito is okay, so mag-generate ako na I think okay lang din pala. Pero kasi unordered to eh. So, kailangan i-maintain yung ano niya. So, hash map is an unordered list eh. So to tapos resist fast token lookup token embeddings table based on sa iterator dito. So 0, 1, 2, 3. Pero kasi ang mali dito is table lookup 0, 1, 2 token ID lookup. Yeah, parang weird. Hindi na preserve yung order niya. So token IDs lookup 0, 1, 2. Sa bagay base pala siya dito sa ano niya. So mangyayari is token lookup IDs for the embedding table look at may token lookup IDs table. Tapos ito yung table embeddings for each niya. Ito yung medyo weird lang. Tapos at gamit ko dito is TIT token embeddings table. So sa token embeddings table, ito siya. So 0. So ito si is. Ito si the unknown. Ito si Ras. Ito si so sa table lookup tama ba? Past. So 2. So si 29. So table embeddings lookup, I will need to look up yung so I think yun yung mali eh. So that's the loophole eh. Yun yung nakikita ko loophole dito na parang hindi maintindihan ni ChatGPT sa akin. Kasi unordered to eh. So, magbabago na naman to once na i-rerun ko siya. So, what I'm expecting here is embedding. So, dapat ito yung 29. And then 607. Tapos, yeah, napunta si 24. So, may mali dito sa embedding stable lookup ko. So, either ako yung may mali sa coding, so meaning dito sa token tables, sa token embedding stable ko, hindi ako dapat dito so ito yung part na may mali ako. Ito isosolve, no? Oh, okay. So, hash map din siya. Oh, wait. Shit. Nalito ko sa kanya. Gulo naman ito. Okay. So, iba yung gagawin ko dito. So, I will do a for each wala dito. So, parang ganito siya. Simple case lang to ha. Kamote. Ba't ganito lumalim? What the heck? I-open ko lang yung Z ko kasi hindi siya nagbibigay ng type hint. Medyo mahirap. Medyo nahihirapan ako sa pag-predict. Ayun, lumabas na yung type hint. Okay. Tokens embedding staple that insert saan mo nakuha yung book? Inanap ko kung may binili ko siya sa Amazon actually. Binili ko siya sa Amazon. Medyo nag-iingat ako sa mga libreng PDF kasi uso na kasi may malware yung mga PDF na yan. Okay, so let's see. Oops. Nga pala kasi tinanggal ko na nga pala yung nag-restart nga pala ako. Okay. Mukhang kailangan ko initialize sila, no? Okay, parang may mali ata ako dito. Anong nangyari? Insert. Kasi ang nangyari is it's kasi token ID daw yung mangyayari. May mali ako dito. With capacity of embedding deal. Ayan, okay na. So, i-analyze natin. So, RAS is fast. I think gusto ko yung medyo random. Ayoko nung ayun, pagka nag-random siya na ganito, dito nagkaka-problem. So, kailangan ko i-define muna sila. nangyari? Option unwrap 87. Oh no. Dapat yata update. Kamote naman yan. Paano ba to? So, hindi siya dapat insert pala. Get mute pala dapat to, ano? Get mutable. Or baka pwede siguro to. Okay, ito maganda rin tong part na to. So here, so RAS is fast. So 0, 1, 2. So ginawa niya dito is minap ko na siya. So 0, 0, 0, 7. Tapos is 1, 0, 1. So 0, 0, 5 is fast. So 3 siya, tapos 3, 6. So now, I'm going to intentionally move the unknown token ID to index 2. Tapos, eto. Then 3 to. Para mas makita natin na dapat. Ayan, okay din to. Yan lang yung aking okay, so here, okay, 1, tama. So dapat ang embedding ko is 0 ito siya is 1, ito, and then fast is so 819126. Ayan, okay. So gets ko na. So tama na ako. Of the embeddings dimension. Generate the embeddings. Sana naintindihan niya ako. Okay. Final output embeddings, okay. Wow, it took me 3 hours and 30 minutes for embeddings. Probably still not finished. I still need to use some tools here like bun and the array. But let's see what ChatGPT going to give me. But I think I will try to per chat. I will do the per topic. It seems that if I'm going to do this per every topic, it's going to be a long chat. So mas mabagal siya. Nahilo ako dun I mean, actually nagutom ako. 10 na pala. So, isip ko magluluto pa ba ako. Yeah, I think I'll just cook na lang. But tutuloy ko to later. Because nagdadabog na rin yung aso ko. Mukhang nagugutom na rin siya. Pinantagal. Piling ko kinover ko na lahat ng Kinover ko na rin yung tokenization. Naglalagyan ChatGPT. Ano nangyari? Bira. Tagal?
Oh no, I already doing tokenization. Okay. I'm already doing it na pala. So that's why ang layo na pala ng ginagawa ko. Pero anyways, okay lang din. Tuloy ko lang yung step. I think I'll continue this later. Mag-dinner na lang muna ako. Alright guys, thank you and bye-bye.